Namaste, welcome to Pythagoras Academy. This video is to explain you how to deal with the problems like this in mechanics. Students, when they look at problems like this, where a pulley is attached to the block, they feel this is complicated. The reason is that they fail to draw a proper free body diagram in these kind of scenarios. But let me tell you, it is very easy. All you should know clearly is how to deal with the problems where a pulley is attached to a block. The point is, whenever the pulley is attached to a block, for example, in this case, if you observe the bigger block of mass capital M, it is not just the block, it is block with a pulley. And look at the forces acting on this. Because it has got mass, the weight mg is acting down, it is in contact with the ground, there is normal force by the ground. It is also in contact with the smaller block, so there is a pushing force of N1 to the left. These are the three external forces which are very easy to be identified. And apart from these three forces, because the pulley is attached to the block, let us see what are the forces acting on the pulley. There is one tension due to the string towards right and another tension downwards due to the same string. Because it is the same string, the tension is T. Considering ideal pulley and ideal string, light and inextensible string, so tension is same everywhere. Massless and frictionless pulley, so tension is same on both sides. There is no rotational effect of the pulley. If the pulley has got some rotational effect, that's a different story. Maybe that we'll do in a different video. But now for this ideal pulley, tension on both sides is same. So it is T down and T towards right. Now when you draw the free body diagram of this mass, representing all the forces acting on the mass, there is weight mg down, normal force upwards, and another normal force towards left by the smaller block, and two tensions, tension T towards right and tension T downwards. So whenever the pulley is attached to the block, all the forces acting on the pulley are in turn acting on the block. This is the idea, this is the concept. So if you know this, you can deal with any problem of this kind. I'll take another example. So once, if you want to look at this free body diagram, apart from the three forces that we are able to easily identify, I have also represented the forces acting on the pulley because the pulley is attached to this block capital M. And coming to the smaller block, free body diagram, it has got weight down and tension T, and the counterpart of this N1, this is action and the reaction is this N1. It's very simple. Let us go to another example. Yeah, look at this. Now let us follow the steps. I am first drawing the free body diagram of capital M. So for capital M, the forces are mg downwards because it has got mass, then weight is acting downwards. It is in contact with the ground, so there is normal force N upwards, and it is in contact with the smaller blocks, so normal force is always a pushing force. So smaller block is pushing the bigger block towards left. So this is N1, and the tension is directly connected to the bigger block. The string is directly connected to the bigger block, so there is tension T towards right. These are the forces. And you should not forget that the pulley is attached to the block M. All the forces acting on the pulley are in turn acting on the block. So I should represent the forces acting on the pulley. Observe the forces acting on this particular pulley. There is tension T towards right and tension T down. I am applying these forces here. So there is tension T in yellow and tension T downwards. These yellow tensions are the tensions acting on the pulley, and because pulley is attached to the block, in the free body diagram of the block, these forces come into picture. Now, if the question is what is the normal force exerted by the ground on the block, in all the cases, I am first taking smooth surfaces. Don't worry about friction now. So even in the previous case, this is smooth, there is no friction, I haven't considered friction. If the question is what is the force exerted by the ground on the bigger block, that is N, so by application of Newton's laws, in the vertical direction there is no acceleration, so N is equal to T plus mg. So this is what you have to observe. If this concept is clear, then you can solve any problem of this kind. So n is equal to t plus mg. So most of the students will always think that n is always equal to mg. But no, in this case n is equal to t plus mg. This t is the result of the pulley being attached to the block. So this is the concept that one should remember. And coming to the free body diagram of the smaller block, it is so simple. Mg down, t up, and n1. Later on, take the acceleration and getting the equations by applying Newton's law, solving for the acceleration. That's a different story altogether. This video's intention is only to explain how to deal with the blocks where the pulley is attached to them. Yeah. So that's all about it. In another video, we'll come up with more interesting concepts. So keep following. Thank you so much.